Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The topics of this video are starter motors, alternators, and ISG, integrated starter generator. As you may know, a starter motor starts an engine by rotating the flywheel at the rear end of the engine. An alternator is a generator that is rotated by the engine. Nowadays, some hybrid vehicles have an ISG, integrated starter generator that integrates the functions of the starter motor and alternator. You might imagine a starter motor configuration like this illustration. If you hear, turning the ignition key to the start position is the starter motor and rotating the engine. However, for two reasons, it's not quite that simple in reality. The first reason is that the starter motor needs an electric current of over 100 amperes. The wirings and contact of the key switch cannot manage such a great electric current. The second reason is the rotational speed. Typically, a starter motor rotates at 200 to 300 RPM, whereas after the engine starts, it runs at 600 to 800 RPM. Therefore, it is necessary to disengage the starter motor from the engine after the engine has been started. The solution to these issues is the magnetic switch. First, let's take a look at the structure of the starter motor. At the top of the motor is the magnetic switch, consisting of a plunger to engage and disengage the pinion from the flywheel, two coils to move the plunger, and a main contact for controlling the great electric current. When the driver turns the key switch to the start position, electricity flows to the pulling coil and holding coil of the magnet switch. Because these two coils are wound in opposite directions and the electricity flows in the opposite direction of each coil, the magnetic force is generated in the direction of pulling the plunger. At this time, a small amount of electricity also flows to the motor, slowly turning the pinion, making it easier for the pinion to engage with the flywheel. When the plunger is pulled, the pinion is engaged with the flywheel, and the main contact is connected, allowing a great electric current to flow into the motor, causing it to rotate at high speed. At this point, the current no longer flows into the pulling coil due to the potential difference, but the holding coil remains to generate magnetic force, keeping the plunger in the engaged position. When the driver determines that the engine has been started, and then returns the key switch to the on position, the starter switch is turned off, interrupting the electrical flow from the starter switch to the holding coil. However, electricity flows from the main contact to both the pulling coil and the holding coil, and since these two coils are wound in opposite directions, they generate magnetic forces that cancel each other out. As a result, due to the spring force of the return spring, the plunger returns to its original position. Today, key switches have been replaced with start-stop buttons. The engine control unit determines if the engine has been started. Therefore, drivers can start the engine with just one press of the button. An alternator is a three-phase alternating current generator that is driven by the crankshaft pulley of the engine via a belt. While the engine is running, the alternator supplies electricity to all electrical components such as headlamps, wipers, air conditioning, spark plugs, fuel injectors, electronic control units, etc., and also charges the battery. The coil generates electricity when the magnet is moved close to or away from a coil. This electricity is generated in an alternating current, where the direction of the current varies based on the polarity of the magnet and the direction of the magnet's movement. In alternators, to accommodate the mentioned output limitations, electromagnet that is magnetized when electricity flows through them, are used instead of permanent magnets. The fixed coil that generates electricity is called the stator coil, and the rotating coil is referred to as the rotor coil. An alternator generates electricity by combining three sets of stator coils, each producing electricity in a different direction and at a different voltage. As a result, they cannot be directly connected to the car's electrical circuit. A rectifier, utilizing 6 diodes, is installed at the rear of the alternator to convert the AC electricity generated from the 3 coils into DC electricity. A diode is a type of semiconductor that possesses the property of allowing a current to flow in only one direction. A rectifier utilizes the action of diodes, which allow currents generated by each coil to flow in only one direction, thereby converting AC electricity into DC electricity. The rectified direct current electricity operates each electrical components and charges the battery. The waveforms represent the rectification process. The three alternating current waveforms are converted into direct current waveform. To generate sufficient voltage even at low engine speeds, the alternator rotates at a higher speed than the engine. However, as the engine speed increases, the generated voltage also increases, and if the voltage exceeds a certain level, it may cause damage to the battery and electrical components. To prevent this, a voltage regulator is equipped. During low engine speeds, the voltage regulator applies a significant amount of electricity to the rotor coil to generate an adequate voltage. As the engine speed increases, the voltage generated also increases. For controlling output voltage, the voltage regulator reduces the electricity applied to the rotor coil. Then, the magnetic force of the rotor coil decreases, leading to a reduction in the generated voltage of the stator coil. In this manner, the alternator controls the generated voltage to around 14.5 volts, regardless of the engine speed. Rectifiers and voltage regulators are electronic components and they generate heat. To dissipate this heat, the alternator has numerous ventilation slits and is equipped with a cooling fan at the front. This is why alternators must be covered with a plastic bag or similar material when washing the engine compartment with a high-pressure washer. In recent years, there are car models that perform precise control by monitoring, not only voltage but also current flow to enhance fuel efficiency. When electricity flows in a coil that is placed between magnets, the coil rotates. This is an electric motor. On the other hand, when the coil is rotated using an external power source, the coil generates electricity. This is a generator. In other words, electric motors and generators can fundamentally use the same device. Because mild hybrid vehicles frequently stop and restart the engine with idle stop functions, they utilize ISG, integrated starter generator, combining the starter motor and alternator. The belt-driven ISG has a similar shape with conventional alternators, and just like conventional alternators, it is connected to the engine crank pulley via a belt. In some models, the ISG provides torque assistance during vehicle launch and acceleration, not only starter motor function. Also, some car manufacturers, such as Mercedes-Benz and Mazda, install more powerful ISG between the engine and the transmission. Thank you for watching. If you enjoyed this video, please consider subscribing to our channel. We'll see you in the next video.